Hey, hi, and welcome back to another Æther physics. Today we're going to continue on our course of the physical lines of force by Clerck Maxwell. As a reminder, last episode we talked about the stress tensors. We're going to continue expanding these formulas. We're here at proposition 3. We continue to find the resultant force on an element of the medium arising from the variation of internal stress. We have, in general, for the forces in the direction of x per unit of volume by the law of equilibrium of stresses, the formula, and this is going to be the basic formula which expands to a lot of difficult formulas, but it's a cool one. It says that x is equal d dx times pxx plus d dy pyy. Oh, I'm sorry, pxy, because it's all in the x direction. xy plus d dz pxz. The same principle would apply to y is equal to d dx pyx plus d dy pyy plus d dz pyz, and over the z direction is equal to d dx pzx plus d dy pzy plus d dz pzz. This is a pretty big idea, especially when you're seeing these formulas for the first time. You'll be like, what? We're talking about stresses over the x direction, the y direction, the z direction. We can call x, for instance, this volume that we used here, and we say the entire volume goes in a x direction, then we would say that would happen by this entire idea. So what does this even mean? What does it mean when we write this down? What does it even mean to have d dx, d dy, d dz? We call it the infinitesimal. It is about the idea of having a graph, for instance, and you try to reach the smallest difference that you can find in the measure over the x direction. D dx means if we would go the smallest portion, the infinitesimal, the smallest little bit over the x direction, so we go a little bit over the x, what will be the difference in the pxx? Here too, if we go a little bit, small difference in the y direction, what happens over the xyx? And here the same. And what's interesting here is that you might have already recognized it, but we have here our pzz that we had here. With blue, we have here pyy, and with green, we have here the pxx. See? These three. And here we have pxy, pyz, pxy, where is it? Pxy is a red one, pxc is a blue one. This one is a red one, and this one is a blue one. Let me just make it a little bit easier, connect them to the rightful owners. If these are red and blue, then it's got to be a green one here. And you will eventually get a feeling of this. PYZ, yeah, you see, PYZ is a green one here. So if there's a green one here, PYZ, ZY is there. That would be a green one. Then this would be a blue one. And this will be a red one. These three are about the rotating forces, and this is the normal forces, the normal stresses. These are just opposites. And as you can see, this one and this one are opposites of each other. This one and this one is opposites of each other, and this one and that one are opposites of each other, and this is the line that divides either rotating clockwise or counterclockwise. It depends on how you use the formula, but if you would call this clockwise rotations, then that will be counterclockwise or vice versa. We're just going to use the x direction to write down the expression created by all these different parts together, because as you can see, it's going to be a lot of formulas combined together. Brace yourself for a hell of a formula. Big X. Wow, that's a terrible X. the same excess here is equal to, okay, wow. I gotta stand on the other side because this is gonna be a hard one. Here we go. I gotta get down. Man, I can't do this on my own. I need full concentration. 1/4 pi times d mu and alpha divided by dx. So here we have dx. D is 1/4 mu alpha times alpha plus mu alpha d alpha dx. D alpha dx. D alpha dx minus 4 pi times dp1 divided by dx plus. This was the first part. This what we wrote down is just this part. I hope you can see. Second part, that one, dy times px over y would be d mu times beta divided by dy. See? Times alpha plus mu beta d alpha dy. And we're not yet there. That's the end of the second part. Plus, and it's the last part, d mu gamma. Well, I hope you enjoy this, me trying to figure it out. dz alpha plus mu gamma d alpha dz. Okay, I can understand that you're like, what, dude? What happened? How do we end up with a formula this big? It is only this x. You see? Let me try and figure it out. As we can see, there are 3 parts of this. Here we have the green part. Well, until here. The red part will be this part. The final part will be the blue part. Here. Here. There. And there. Easy, huh? What happened here? How do we end up with a formula this big? How do we do this? I don't know. I'm confused. What can we recognize here? We recognize here that we have the mu here and mu there. Mu here, mu there, mu here, mu there. So these mu's came from somewhere. Here we have a mu, here we have a mu, here we have an alpha. So how did this happen? What happened here? Everywhere is 1/4, as you can see. 1 divided by 4 pi, 1 divided by 4 pi on all these parts. So what Maxwell did was saying, okay, everywhere is 1 divided by 4 pi times something. So what we can say is 1 divided by 4 pi times everything. That's the same as saying that you put this part here and another time there and another time there. As you can see, it's getting very, very hard, very, very quick. And we only did it over the x direction. We didn't even do it over the, even try and write it down a little bit easier. And this is the part where it gets a little bit more understandable. It is known in physics for, well, he wrote it down that it is known. So, and he wrote this paper in 1865, I guess. So it's a long time ago. There is a known formula that we can write down as follows. This is only about an x-axis with alpha, beta, and gamma. If we say alpha times d alpha dx plus beta d beta dx again, am I right? Yeah. X plus gamma d gamma dx is equal to a half d dx over alpha squared plus beta squared plus gamma squared. A little bit easier. So we can use this formula here and apply this idea to that huge formula here. And if we do that, the equation is going to look a little bit more understandable. I'm going to write down that equation, and after I wrote down the equation, I think next time we can get into it. Terrible idea to try and explain this. I thought it would be cool. I thought it would be easy. I thought I could do this. Yes, I can. Yes, we can. We're gonna make ether physics great again. Okay, here we go. I've never been in the position of making the vlog with this kind of equation. I always try to keep it simple, and today I thought, well, what the hell, I don't give a crap anymore. I'm just gonna do it, man. I'm just gonna write down all these equations and gonna vlog in some kind of way, because I like writing down these equations, because they're so hard to understand, man. Man, I get all excited when I'm doing this, man. I should do this more often. If we try and put this equation, put the laws of this equation in this equation, we get a more convenient equation that looks like an x, again, is alpha, 1 over 4 pi. Again, we open it and say d dx times mu of alpha plus d dy mu of beta plus d dz of mu of gamma, 1 part. Okay, still alive, still alive. Okay, this is the first part of the equation. Plus 1 divided by 8 pi mu d dx alpha squared plus beta squared plus gamma squared. This is going to be the second part of the equation. Minus, again, mu times beta 1/4 pi d beta divided by dx minus d alpha divided by dy, I guess. Yeah, y. First, second, third. Now it's the fourth part plus. And we're gonna make it. I think we're gonna make it. I was scared that I might not make it till the end of the board, or that I didn't have enough room. 1/4 pi, and we open it, and then it's d alpha again divided by dz and minus d gamma divided by dx, and it's almost the last part. And here is the final part of the formula: dp1 divided by dx. Can you actually believe it? We did it. We actually did it. We wrote down an enormous formula talking about rotation of fluids. Man, it's gonna be hard to explain this. That was a terrible job. I hope you enjoyed me trying to write down these terrible, huge equations, which I actually enjoy a lot of doing, as you can see by the huge smile I'm having on my face. Because I know I probably messed up in my explanations somehow, and I think next video I'm gonna rewrite the equation, not letting you have to watch me rewrite it all over again, except maybe you like it to see me struggle with these equations. But I think that in my next episode we're gonna talk about what these 5 different parts of this equation actually means in the physical world, or in the ethereal physical world of the electromagnetic phenomena. Damn, man, that was a lot of fun, wasn't it? Oh my gosh, it's gonna be so much fun trying to figure this out, because I've been over all this before. I've used a lot of my precious free time to figure out what the hell this man was talking about and what all these equations mean. And if you one day understand these equations, then you mastered physics. I'm quite sure of it. And none of the physics that you will ever read is going to be much harder than this, because this is, I think, almost the hardest part of physics. Maybe the hardest part of physics is trying to understand quantum mechanics, which we will talk about in another time, but it's going to be a hard time trying to explain the laws of quantum mechanics in this ether model. But hey, we can try, man. We can try. We can figure it out. And if we can't, then we can't. Who cares? We're having a lot of fun right now. We wrote down some terrible, huge equations. So yeah, thanks a lot for watching, and see you next time.